All right, we're on to part 2 or lesson 8 from day 4. And part 2 involves this goal right here, which is I understand that the graph of a periodic function can look like a wave whose outputs repeat between the same maximum and minimum, the same minimum values. So what is a periodic function? We talked about that earlier in the unit. You might have forgotten, but a periodic function is a function whose values repeat at regular intervals. And those regular intervals are called periods. So when every period, a periodic function repeats itself, and so the period is the length of the interval. So we're looking at periodic functions, and periodic functions are going to have outputs that repeat between that function's maximum and minimum values. So think about these vocabulary words we use: maximum, minimum values, period, periodic function, and I would like for you to pause and jot down some notices and wonders and try to use that goal or use those vocabulary words in the goal when you are doing your notices and wonders. Okay, did you notice that the graph goes up and down? We have a maximum of approximately 1.8 miles, a minimum of 0 miles. Hopefully you notice that this graph represents a periodic function, and each one of these highlighted, it stops here, but if it continued, then we would have 3 intervals or 3 cycles or 3 periods of this periodic function. So each cycle, so a period is also known as a cycle. So each cycle was about 1.8 minutes, right? It ended every 1.8 minutes. You can see if this had continued, but it didn't. So those are some things you might have noticed. You might have wondered, hey, what does this graph represent? Or what is happening when the distance is 0? You know, over time, this is a distance from the start line. So what's happening? Distance from the start line, getting farther and farther away, getting closer to the start line. Farther and farther away, closer to the start line. So what's happening here? We're going to talk about that soon. But again, this periodic function, how do we know? Well, the values repeat at regular intervals. We can see these intervals right here represented by the colors. And the length of each interval is a period, which we noticed here. And does it have some maximum minimum values? It sure does. Does it repeat in between those maximum minimum values? It sure does. Does it look like a wave? Yes, it does. All right, so let's talk about what is happening, what's happening with this graph. So here are some relationships that produce graphs. So we're only going to focus on the first one. We're not going to do the other ones after this. So I'm just focusing on this first graph in your notebook. So for each situation, for this particular situation, I want you to try to describe what is happening with the independent and dependent variables. Which one's dependent and which one's independent? And how does the dependent variable change? What might cause this? So look at this based on what you see here. Which one's dependent and which one's independent? So hopefully you were saying the x-coordinate is the independent variable, and the y-coordinate is the dependent variable. So now that we've just reminded ourselves of which one is independent and which one is dependent, go ahead and pause and try to describe what you believe is happening. Okay, so I drew a little picture over here, and this kind of reminds me of like a racetrack or something. So because we have the distance from the start line in miles, and then we have the time in minutes. So I guess it said a race car. I didn't even realize that. Sorry. It says a graph of the distance of a race car from the starting line goes around the track. So here's my track. So I had to start on an end. Why did I have to start on an end? Because I'm going as far away as possible up here. If I'm approximating this to be 1.8, that means as I went around, I got farther and farther away. So this would be that point up here. However long that took, a little less than a minute to get to the opposite side, the farthest point away from the start line. And then I would continue around the track. The distance is getting closer and closer and closer back toward the start line, right? So these Values are getting smaller and smaller and smaller. So you're starting at the start line, you're going away, so the distance is getting bigger and bigger and bigger, and then you're going back toward the start line, so it's getting closer and closer and closer. So what's happening at 0? Well, that means you're getting right back on that start line again. So now I'm here. I go around a second time. It takes me the same amount of time, a little bit less than a minute to get to here, halfway around, then I go back. So I come back down. So that's how it's continuing. And then I get to this point. So I get to the start line again, and then I go around. So I'm back, I'm all the way to the opposite side. But then what happens? Do I make it to the start line? No, maybe the finish of the track is right here. We don't know. But it looks like you don't quite get there. It doesn't even look like it's halfway. It's a little bit less than halfway, so I'd say this is halfway. So that's why I would start approximately there. So the independent variable is time. So it says, how does the dependent variable change? Well, it gets bigger, and then it gets smaller, and then it gets bigger, and then it gets smaller. And what might cause this change? Well, we just saw on this visual over here what was happening. So now let's look at this. Are you ready for more? I would love for you to try this. Go ahead and pause and try this on your own. I would draw a picture of the ladybug resting at the tip of a clock's minute hand, which is 1 foot long. When it is 12:15, the ladybug is 10 feet above the ground. So if I make the ground here, I'm going to make a clock up here. So here's the center of the clock. The ladybug is at the tip. So we'll say here, it's 10 feet off the ground when it's 12:15. So 12:15, it's going to be over here, right? It's going to be 1, 2, 3. This is 12. So at 12:15, the ladybug has to be pointing directly to the right. So this is 10 feet above the ground right here. And then it says that the minute hand is 1 foot. So just this, I know I'm a little bit distorted here, but this red part and green part is 1 foot. And even this blue part right here is 1 foot. We'll make that yellow. So all of those are just 1 foot each, because the radius or the minute hand of the clock is 1 foot. So use that diagram and calculate how far above the ground is the ladybug at 12 o'clock, 12:30, 12:45, 1 o'clock. And then you can try the number 2 and then graph it in number 3, and then unpause and have a look. But you should be able to do 1 for sure on your own, hopefully 2 after what we did earlier in this unit on the first lesson, lesson 7. So go ahead and look back at that and try to do number 2 as well. Okay, so did you get for 12 o'clock, the ladybug is 11 feet in the air. For 12:15, it's 10 feet. 12:30, it's 9 feet. 12:45, it's 10 feet. Right, so we have the 10 feet, and then plus the 1, that would be 11. Then it goes down to 10, then it goes to 9, then it goes to 10, 11, 10, 9. So we go from 11 to 10 to 9 to 10. So we have those in the blue color here. Sorry, I went over them in red. That was 10, then 9, 11, then 10, then 9, then 11, then 10, then 11 again. And then in the red, how would I get 12:10? Well, 12:10 was right here. That was pi over 6, because it's 1, 6, 2, 6, 3, 6. So 12:05, 12:10. So 12:10 was a rotation of pi over 6. So sine of pi over 6 is 1/2. So I add that 1/2 onto the 10. So I get exactly 10.5. So here at 12:10, it was 10.5. Then it's 9.5. Then it's 9.5. Then it's 10.5. So again, if the ladybug stayed on there, this would be a continuous motion. It would be like this, and they would all be connected. If the ladybug stayed on and went around and around and around, this would be the motion. So if the ladybug stays on the minute hand, how will the graph change, or what will happen? Well, it'll just keep going, right? So it'll be from hour to the next hour to the next hour. So your period is that hour, one length, 60 minutes. And then you would see another of the same exact graph from the maximum to the minimum to the maximum over the next hour, another 60 minutes, and then another 60 minutes. You would see the same thing. So there you have it. And finally, this is a question from your homework, the day 4. It's question number 5. I would just like for you to have a look at this just to wrap up this particular lesson. So I didn't do the synthesis because I think this is going to be a little bit better. Again, remember our goal was to know that there was going to be a maximum and minimum and have that periodic function repeat between that maximum and minimum, and those values repeat over and over again. So that is what we have seen as we've looked at these graphs. So if you look at this particular question, it says a fan blade spins counterclockwise once per second. Which of these graphs best depicts the height h of P after s seconds? So here is point P. So you think about this. This is your y-axis. This is your x-axis. And this point P is going to go counterclockwise, so it's going to go around this direction. So it's going to go around and around and around. So which of these graphs depicts it? Well, if this is your x-axis right here, whoops, if this is your x-axis right here, then this is starting at 0. And then what is happening as time goes on, we are looking at the height of that point. So if it's going counterclockwise, that means it's going up and to the left, and so the height is getting taller. So this could be that graph. Could this one be the graph? No. Could this be the graph? No. But this could also be that graph. So how do we know which graph it is? Well, it says it's going to complete one cycle, in s seconds. So the fan blades are 1 foot long and the height is measured in feet from the center of the blades. So here it is. The blade spins counterclockwise once per second. So once per second, that means it goes from this maximum and then it goes down to the minimum and back to 0 again in 1 second. So it goes to its maximum, back to 0 again, and down to its minimum. So it goes to its maximum, then it goes to 0, then it goes to its minimum, then it goes back to 0 in 1 second. Did that happen here? No. So this right here, what would have happened with that blade? How would you describe the blade for this graph? So then let's go to this graph here. So here it would go up 1, then it would go down to 0, then it would go back down to this -1 here to its minimum, and then back up to 0, right? It went to its maximum, then it went to its minimum, all within 1 second. So this is the correct graph depicting that. Again, why? If you have your x-axis, your y-axis, your start here at P, went to its maximum, went to its 0 point again, then it went to its minimum, then it went to its 0. So here it started at 0, went to its maximum, went to its 0, went to its minimum, went to its 0. That was one cycle around that fan in a circle in 1 second time. So what happened here? This made 2 circles, right? So it would go around once, it went around twice. So this means it was able to complete one cycle in 1/2 of a second. So it's twice as fast as this one down here. What about these two? What is the impact that these two are having? What is this representing if you were to look at that? This time from 0, it's going down to its minimum, and then to its maximum, down to its minimum, then to its maximum. So it's starting here and going down to its minimum, then up to its maximum, then down to its minimum, then up to its maximum. So it's going the other direction. So this one is going clockwise because it's going down first. Which one is going to complete one cycle in 1 second? This one is going clockwise first, but it's going to complete to the minimum, to the maximum, and back in 1 second. So it's just one loop, where this one is one loop, and then it's a second loop, so it's twice as fast, or it's completing one cycle around that clock in 1/2 of a second. So again, just trying to get your head around what's happening there. Hopefully that's helpful, and go ahead and practice those practice problems. Bye.